We have number 4 here. We're finding the measurement of arc EF. So where is EF? Oh, we know that EF is right here. Right? And we need to find a way to get that. Well, notice that this is the diameter. Notice this is the diameter, right? And then this is also the diameter as well. Okay, so the fact that these two are diameters that cut from each other, you could set up the equation, but in short, this does just get you this part is equal to this part. Okay, so you can say that the arc of GF is going to be equal to the arc of DE. Okay, and the reason why we do this is I want to get X first. All right, so this is 13x plus 3 is going to be equal to 15x minus 7. Subtract 13x to both sides. This does cancel, bring down the 3. 2x minus 7 plus 7 to both sides. This cancels, leaving you a 10 is equal to 2x. Divide by 2, divide by 2. This cancels, leaving you 5 is equal to x. Okay, why do we do that? Because we can actually plug this in here for GF. GF is 13x plus 3. Make that substitution for x as 5. So now we have 13 times 5 plus 3. That gets you 68 degrees, okay? So this is 68 degrees. We can get this part, which is in red. So that red part of EF, if we add that to 68 degrees, that's going to get us our total semicircle of 180. So watch as I just subtract 68 from both sides. I will get now the new arc. Okay, my new arc 180 minus 68 gets you 112 degrees. All right, so there you go. Again, if you don't believe me, you have to see how this will also be congruent. Why? Okay, very simple. Ready? Vertical angles. Okay, vertical angles. All right. Okay, that's why. Right? If these angles are congruent, right? If the vertical angles are congruent, okay, are congruent, then the central angles have to be congruent. Do you see? If the central angles are congruent, therefore their arcs have to be congruent. Okay, that's the explanation.